This little video I'd like to show how to set up the Raspberry Pi to use it inside our Andino X1. We are here on the website of the Andino X1. It's andino.system/Andino X1, and when we scroll down, here we see the Andino. It's a DIN rail housing with a little motherboard inside, which contains a power supply, some digital inputs, isolated relay outputs and extensions. A little bit down here we have the motherboard with the Raspberry Pi plugged head down inside this housing. This is the old screw terminals. We have found some better ones, and this is the version we deliver from now on. All the Raspberry Pi we deliver inside the Andino X1 are the 3B plus version. Okay, here we have the block schema of the X1. We have the Raspberry for sure, power supply with 9 to 24 volts and 3 amperes, and the Raspberry and a microcontroller. The microcontroller handles the input and the output, and optionally it handles some shields, analog input, what else, CAN bus via the E2C, I²C, don't know the English, or the SPI interface. The communication between the microcontroller, which can be programmed via Arduino IDE, the interface between the Arduino controller and the Raspberry is the TTY AMA0, which is initially not mapped to the plug header of the Raspberry Pi, the pin header. So we have to install a little overlay, and then we can use this interface. On the other side we have this real-time clock. Here we find the instruction. All our instructions and documentation for the Andino products are inside GitHub. So we have here how to set up, and here we are in GitHub where the documentation is. And here we will find what we have to do to enable the UART to communicate between the microcontroller and the Raspberry. I prepared a fresh image. It's the latest version of the Raspberry, and we have to add some lines to the boot.config. So I think we can do it here live. boot/config.text sudo nano, and at the end of this file we just copy and paste these lines. Close. Then the next problem is that it's Getty tries to bind a shell to the UART interface, and we have to disable it, and this we can do inside the boot cmd line config. So let's edit this cmd line config. So here we see the console, serial 0, the baud rate, and we have to delete this part. So you can see it here on the website. So far so good. And now we have to reboot. Takes a little time. In the next step we can try if our changes are worked. Okay. The easiest way to check the communication between the Raspberry and the Arduino controller is with Minicom. I just install Minicom. Okay, after the reboot and the login, I have to update the Raspberry and then we can install the Minicom. We can use apt. Okay, the Minicom is installed, and now we have to set up it, and we need to do it as sudo, I don't know why, sudo minicom -- setup, and here we go to setup serial port, and the speed is 38400D. Zack. And hardware flow control we set to no. F is to no. So this is right settings. 83400, 8 and 0, and no flow control. And we can go to screen and at the local echo, it's Q. Local echo, and save it as default. And now we have to restart it. And no, we don't need no longer sudo. Ha! I forgot something. The interface in the serial port setup A is for sure AMA0. So now it's okay. Save as default. Exit, and now Minicom. Okay, and now we can see what the Arduino microcontroller sends to the Raspberry. This is a message. I show it later in the on the web. Now we can send commands: relay 1 to 1, relay 1 to 1, relay 1 to 0. And you can hear it's just switching. Okay, the firmware documentation about the firmware is also on the GitHub. Andino X1 source, counting. I called it counting. This is the default firmware that we deliver. And we have some commands. For example, the microcontroller debounces the input, and for this it scans the input in a cycle. This is a pole cycling, and we can set up the cycling in milliseconds. This is in which distance the microcontroller looks at the inputs. And then we have the debow configuration, which says how many times the value has to be the same. That is read from the input. Okay, now we can start Minicom. And what we can see is that the microcontroller sends strings to the Raspberry. The strings has some parts. The first part is a message ID. It's just a number counting from 0 to FF and starts again. It's just to see that the microcontroller is still alive and we have no message lost. Then we have two parts. Of the first part here is are the counters, which counting the events, and the next part are the states of the input. So if I press the button, the state goes to 1 and the counter goes up. If I release a button, the state goes down. We have a description of this default firmware. It's also in GitHub. So if you go to Andino X1 in the GitHub and below source counting and a little bit down here, you can see all the commands you can send to the microcontroller. One of the command is info, and here we get the current settings. We have here some two important parameters. The first is the poll, which is 10 now. This means the microcontroller polls every 10 milliseconds the input. And then we have a debow, it was 3. This says that the input has to be stable 3 times. And after that, the state is accepted as a state change. This is a debouncing, so very short spikes we filter out with this method. You can change the scan rate and the debounce, whatever you like. And then we have a edge. You can see by default is when the edge goes to 1, the counter counts up, and if I release it will not count. You can change this behavior by set the, what was it here, the edge to 1. It's now edge is 1, low high, you have to set this to 0. You can change the cycle in which the microcontroller sends it to the Raspberry, and you can set the relay 1, it was a mistake, relay 1 to 1, relay 1 to 0, or you can pulse the relays. It's F1 10. That means 10 times 100 milliseconds is the pulse of the relay. The source code of this firmware is also here. It's counting.ino. Yes, you can change it if you like. And here's also a description of the message format. Okay, I go back. The last thing we can more technical info in the dock. So the serial port we have enabled to the pin header, and if you like, you can install the driver for the RTC, the real-time clock. It's also very easy. It's a little bit boring if I show it here. Just add some lines to the config and execute some commands, and then you will see the RTC will be found on the I2C bus, and then you can read the hardware clock and write the hardware clock. And I have a little script here. It's a script which writes the hardware clock if we have an NTP connection and if we lose the NTP connection, the hardware clock is be read from the clock will be read from the hardware. One little thing, if you like to exit from the Minicom, you have to press Control A and then X. So it's Control together with A and then release and press X and leave exit. So that's the trick. So that's all for this time. Next time I will show how to set up the Node-RED.